Hello everyone, how's it going? I hope you are great. Welcome to this video. This is the video part number 6 from the test driven development video series, and if you didn't watch the video part number 5, you should watch it at first and then watch this video. Okay, what's on the agenda in this video? Same as the last video, today we are going to complete the Soundex class implementation through test driven development. The cycle of TDD, once again in brief, is to write a small test, ensure it fails, and then get it to pass, and then review and clean up the design, and finally ensure the test all still pass. As you saw in the last videos, we designed the Soundex class step by step and incrementally. Actually, incrementalism is at the heart of what makes TDD successful. An incremental approach maybe will seem quite unnatural and slow at first, but however, taking a smaller step will increase your speed over time, partly because you will avoid errors that arise from taking large and complicated steps. An incremental approach allows us to build the system piecemeal in any order with continually verified and forward progress. Alright, let's take another step to complete the Soundex class, but before that, don't forget to check out the session 6 branch. Let's do it. Open up the Visual Studio Code on a status bar, click branch button and click session 6 branch. Okay, take a look at the test cases. We've written 3 test cases, and final test cases was replaces consonant with appropriate digits. Okay, and take a look at Soundex algorithm rules. We were working on this rule in the last video. Okay, I think we need to test drive more of the consonant conversion logic in order to generalize our solution. And there is a question here. Should we add an assertion to this test case? I mean, replaces consonant with appropriate digits, or should we create an additional test? Okay, let me tell you. The rule of thumb for TDD is 1 assert per test case. It's a good idea, and we will follow this rule most of the time. Another assertion that represents encoding a second consonant doesn't seem like a distinct behavior. Do you agree with me? Also, if we would want to add it to a new test case, how would we name it? Do you want to name it to, I don't know, maybe replaces B with 1? Or the next test case replace the C with 2? I think it's not a good idea, because every test case should describe a behavior, and this kind of assertion or this kind of test cases doesn't seem like a distinct behavior, another behavior. Alright, at this point we are going to make the rare choice of adding a second assertion to this test case, but we will fix it very soon. Let's do it. Assert, we can copy the previous one and pass it a new value AC, and we expect A200. Alright, I would prefer that if one assertion fails, the others still execute. To accomplish that goal, we could use the expect that instead of assert that. Alright, let's run test cases again to make sure it's failed. Alright, at this point you can see the second assertion is failed. Alright, let's get it to pass. Open the Soundex header file. How could we fix it? In encode digit, we could get a char, and then we can decide based on this char, and this is the first char of a word. If letter equal to C character, then return 2, and at this point we should pass the first letter of the word. I mean the second one. Alright, let's run the test cases again. Alright, we are done. It's passed. Okay, add the third data case, copy the previous assertion and pass the new test case. AD, and I expect it would be A300. Run test cases again to make sure it's failed. Okay, it's failed. Let's pass the test case. I've got a question. Shall I add a new if statement at this point, like this? I don't think so. The need for a third consonant makes it clear that we need to replace the if structure with a hash-based collection. Actually, we need a map from char to a string. Okay, let's do it. I'm gonna use unordered map. Sorry. And at this point, as I told you, we need a map from char to steady string. Okay, encode things, and let's initialize it through braced initializer. Map B char to a string 1, the next one for C map to 2, and third D to 3, and we can remove this if structure and to search in this unordered map we can use find function. You should pass the letter as an argument. Okay, what's wrong? Okay, the find function actually returns the iterator that point to the element, and the element, it would be a steady pair. And what we need the value. For get the value, we should call the second. Okay, we are done. Let's run test cases again to make sure it's passed. Okay, all of the test cases are passed. What we need now, we need to code support for the rest of the consonant conversions at this point. I mean to this map table. And there's a question here: do we need to test drive all of them? I mean all of the consonant, or add a new assertion for each one? It's a really important question. Let me tell you something. An old saying in TDD is test everything that can possibly break. And I think coding encoding map, like what we have done at this point, is a low risk activity. It's really unlikely we'll break anything in doing it. Okay. There is another counter argument, which is you can break anything and no matter how it's simple. Okay, let me give you a strong answer. Suppose here at this point in this conversion table, we have hundreds of elements in this table. Do you think we are supposed to add an assertion for all of them? Absolutely we don't. It's ridiculous. Alright, I don't want to bore you with all the details. What should we do right now? Let me clarify for you. We are test driving, not testing. And maybe you ask me, is there any difference between test driving and testing? The short answer is yes. If you're going to test it, you would seek to exhaustively analyze the specification, and you have to feed every possible data to your algorithm. But when you're test driving, you just want to drive the design of the code. And your tests in TDD primarily serve the purpose of specifying the behavior of what you will build. They just provide you with the necessary confidence to make subsequent change to the code. Okay, the distinction between test driving and testing may seem subtle, but in TDD you write as many tests as you need to drive in the code necessary and no more. Okay. Okay, we should write tests to describe the next behavior needed, and you know that the logic won't need to change any further. You stop writing tests. Okay, we are going to choose test driving, and I'm gonna let's complete the conversion table. Let's complete it. Map B to one string, and then map char F to 1, the next one P also to 1, and V to 1. Okay, the next row G 2 and also J 2, map K consonant to 2, and Q consonant to 2. We have a lot at this row. S2, then X, x2 the third row D3 the next row map n to 5 and n to 5 and finally r to 6. Okay, I think we are done. What about the tests? Do you think we need 3 assertions in this test case? To answer this question, you should ask yourself whether having these additional assertions provides increased understanding of how the feature works. Let me answer you, probably not. Okay, we can eliminate these 2 assertions, and also we can change this expression to assert that, like previous test cases. Alright, let's run test cases again. Okay, we are done. Our implementation assumes that the letter passed to encoded digits will be found in the encoding map. We make the assumption to allow moving forward incrementally. But remember, to write only the minimal code needed to pass each test. But also, we still have the responsibility of thinking about a letter that doesn't appear in the lookup map. Okay, what should the function do? We can see the rules that we get from Wikipedia. Okay, Wikipedia doesn't answer the question. I think we could guess. We can Google it, an online Soundex calculator. Okay, let's give it an invalid word, and okay, the question is answered. The result is A00, and I think we should ignore the unrecognized characters. Okay, let's write the test case. Test F macro Soundex encoding ignores non-alphabetic copy the last assertion and give it an invalid word, and we expect A00. Run the test cases again. Okay, what happened at this point? The test doesn't simply fail, actually it crashes. You can see at this point segmentation fault error. it means the test program, the test executable file crashes. But why? Let me tell you. Because of this. The find call returns an iterator pointing to the end of the container, and then we try to dereference it. Okay, let's fix it. We can get the iterator at this point, and then we can check it if it's equal to end of the container. We can return an empty string, and else we could return the value of the tuple, the value of the iterator. Alright, let's run test cases again. Okay, what's wrong at this point? Sorry, I made a mistake. Let's run test cases again. Okay, all of the test cases are passed. Okay, that's all we have time for this video. In the next video, we will try to complete the Soundex algorithm implementation through TDD. I hope you enjoyed it. Thanks for watching us. See you soon.